All right, moving on to question number 5. Two identical unlabeled boxes are transported to an orbiting space station. The astronauts know that one box is filled with a light sample of ants for an experiment, and the other is filled with heavy tools for repairs. How can the astronauts tell without opening the boxes which box has the tools? So for this one, I will read the I will read the answers before talking, the possible answers before talking about the concepts behind it. So, option A, weigh each box on a spring scale. The box with the tools will have a higher reading. B, shake each box. The box with the tools will be harder to move back and forth. C, push each box. The box with the tools will travel farther before it stops. D, place each box on opposite sides of a balance. The box on the side that goes down lower will be the box with the tools. E, toss each box straight up. The box with the tools will go higher before coming back down. Okay, so let's go through these answers. A, weigh each box on a spring scale. The box with the tools will have a higher reading. This would not work because there is no gravity where they are. A spring scale would not do anything because you would need a known force applied on the box onto the spring, and you would need to know the spring you would know the spring constant if you had a spring scale, but you would need a known force for it to work that the scale would be adjusted to, and there is no gravity in this situation, so a spring scale would not work because yeah, it wouldn't work. So that's that. Option C would similarly not work because there would be no. If you pushed both of the boxes when there was no gravity and no air or anything, there would be no. It would just keep going until something stopped it. It would go until it collided potentially with the walls of the space station, and then that would be a collision involving some momentum transfer of energy. But in this situation, it would be not applicable to try and see which one went farther before it stopped, because the one that went farther before it stopped would just be the one that hit something farther away. Similarly with D, would not work because a balance needs gravity to work, which there is none of. Same thing with E, tossing both of the boxes up into the air. There's no air, and they would not come back down. So option B is the correct answer, because if you shake the box with the tools in it, it will actually be harder to move back and forth because it will have a momentum that will determine how hard it is to accelerate that box, which is mass times velocity. And while it doesn't have any weight in space, because weight is an aspect of gravity, it does have mass, and the tools have much more mass than the ants. So the mass times velocity of the tools will make the velocity much less for the same amount of energy applied. Whereas the ants, with a much smaller mass, can have a very easy application of velocity with the same amount of energy.